guys, my name is William and I'll be your speaker today. First of all, let me welcome you all to our brand new series, Geometry with Proof. This series consists of lots, and I mean lots, of episodes, as we will be basically covering most of the material from high school geometry. So if you're a middle schooler or a high school student, be sure to follow this series. Trust me, it's going to become very useful in your high school or middle school career. Today's lecture will be a geometry bootcamp. I'll go over the basics of geometry in this two-part lecture. Please also remember to stay tuned for part 2 of Geometry Bootcamp. Alright, let's get started. So first of all, obviously, welcome to the first ever episode of the geometry series. I really appreciate y'all for being here. But what even is geometry? Relax, I'll go through what geometry is step by step right now. Geometry is a mathematical system built on accepted facts, definitions, and terms. Furthermore, as most of you probably already know, geometry is built on the study of different shapes. In this course, we'll be studying several shapes and different dimensions through the use of proofs and axioms. Essentially, just think of geometry as a subject where you examine and judge statements made on shapes and space. Moving on, I'll start by talking about the two main statements that we use in geometry and proof: theorems and postulates. A theorem is a true statement that can be proven, while a postulate is a statement that is assumed. A theorem is a true statement that can be proven, while a postulate is a true statement that is assumed without proof. An example of a postulate is that through any 2 points, there is exactly one line. This fact is assumed to be true and is considered to be intuitive. Theorems, on the other hand, are proven facts. Now let's move on to the new vocabulary that I'll be going over in this episode. First, let's begin with the 3 basic one-dimensional figures: line segments, rays, and lines. A line segment is a part of a line that consists of 2 endpoints and all of the points in between them. A ray is a part of a line that consists of 1 endpoint and all the other points on one side of that endpoint. Last but not least, a line is a straight one-dimensional figure that extends infinitely in 2 opposite directions. If you're struggling with these concepts, which I doubt that any of you guys are, just remember that a line extends without bound, a ray has 1 endpoint, while a line segment has 2 endpoints. Now let's move on to our next 2 concepts. Collinear points, as you guessed it, are points on the same line. Wow, thanks, Mr. Obvious. For example, as seen in the diagram on the right, points P, Q, R are collinear points. On the other hand, points A, B, and C are non-collinear. The next thing on our list, opposite rays. Opposite rays are 2 rays that share the same endpoint and form a line. As seen in the diagram on the right, rays QP and QR are opposite rays. Note that all the points on opposite rays must be collinear. Now moving on to our last one-dimensional concept, intersections. Intersections! An intersection is the set of points 2 or more figures have in common. As seen in the diagram on the right, point E is the intersection between the 2 lines. This should be easy enough for y'all because intersections are pretty intuitive. Alright, moving on to 2-dimensional figures. Let's talk about planes and coplanar points. A plane is a flat and 2-dimensional surface that infinitely extends. Think of planes as figures where an infinite amount of lines are stacked on top of each other. The figure would then infinitely extend in all 2-dimensional figures, which makes it a plane. Coplanar points are, as you guessed it, points that lie on the same plane. Mr. Obvious is back. Alright, so if we look at the example on the right, we could see that points A, B, and F are coplanar on the plane W. This plane could also be named as plane ABF. Alright, now that we have a basic overview of points, lines, and planes, let's move on to the postulates for these topics. First off, points and lines. Through any 2 points, there is exactly, and I mean exactly, only 1 line. If you think hard enough about it, since lines are straight, only 1 line could pass through 2 points. Furthermore, if 2 distinct lines intersect, they must also only intersect at 1 point. These 2 postulates can both be seen in diagrams on the right. Now, postulates for planes. If 2 distinct planes intersect, they must intersect at exactly 1 line. As I previously stated, think of planes as lines that stack infinitely on top of each other. This makes it a lot easier to comprehend the fact that two planes must exactly intersect at one line. The next postulate is about points and planes. There's exactly one plane through any three non-collinear points. Think about it, through 2 points, there is exactly one line. Therefore, through 3 non-collinear points, there can only be one plane. Last but not least, let's move on to the segment addition postulate. This is another very intuitive and conceptual postulate. If 3 points A, B, and C are collinear and point B is between points A and C, then segment AB plus segment BC must equal segment AC. This can be seen in the example on the right. Segment AB is 4 cm long while segment BC is 10 cm long. Therefore, the length of segment AC is 4 plus 10, 14 cm long. Alright, let's sum up what we learned today in this lecture. First off, geometry is the study of shapes in space through different proofs and statements. We then define points, line variations such as segments, lines and rays, and planes. We also define certain terms related to points, lines, and planes, such as collinear, coplanar, and intersections. Last but not least, we explain postulates related to points, lines, and planes. And that's it for today. Thank you for attending today's lecture, and as always, we hope to see you in future videos.